Hello, today we're going to be talking about Chapter 3, Sensation and Perception, focusing into vision and hearing. I'm going to talk about vision, more into light and color. In the retina, there's two different types of light detecting cells, rods and cones. Rods are used to be able to see in low light. Cones is a photoreceptor located in the eye that assists in better vision. Eyes do not sense faces, object, or scenery. Eyes can detect light, electromagnetic energy wave composed of fluctuating electric and magnetic fields. Light travels fast, and as an example, being at Atlanta and arriving to Los Angeles in 10 seconds, which normally it would take about 36 hours since they are 2,181 miles apart. This is my activity video. I'm talking about how those hearing works. The waves are caught by the outer ear and then travel through a tiny channel called the ear canal. The sound waves reach the eardrum, causing it to vibrate along to three tiny bones called malleus, incus, and stapes. The sound vibrations are amplified and sent to the cochlea by these bones. The cochlea is shaped like a snail and it is filled with fluid, which ripples as a result of a sound vibration creating waves. Inside the cochlea, there are hair-like structures that sit on top of the hair cells. They are clustered together as hair cells bundles and they're called stereocilia. The hair cells in the cochlea ride these waves and the hair bundles are moved. These motions are converted into electrical signals. Ions stream into the top of the hair cells and when the hair bundles are moved, generating chemicals released at the bottom of the hair cells. The chemicals bind to the cells of the auditory nerve, generating an electrical signal that travels up the auditory nerve to the brain. Different hair cells respond to different frequencies of sound. Higher pitched sounds are detected by the hair cells at the base of the cochlea. Lower pitched sounds are detected by the hair cells at the top of the spiral. The electrical information is carried by the auditory nerve to the brain, which convert into sounds that we recognize and comprehend. This is my activity for hearing.
As we grow older, we often lose the extreme ends of our hearing spectrum. So, how many of the following sounds can you hear? How old are your ears? Okay, if you can hear 8,000 hertz, you're both alive and not hearing impaired. But let's keep raising the frequency. How high could you hear? If you could hear all of those frequencies, you're probably under 20 years old, but that won't last forever. Unlike other organs such as the liver or skin, the inner ear does not have the capacity to regenerate. In your ear, there are thousands of tiny nerve cells called hair cells. These are responsible for picking up different frequencies and sending the signal to the brain where it's processed. But as you age, the continual exposure to noise and loud sounds can break, bend, and destroy these cells. So why do the high frequencies go first? It turns out that the hairs tuned to high pitches are the first to encounter sound waves. As a result, they experience more stress and tend to degenerate earlier, which is why the older you are, the harder it is to hear high pitches.